Hello, everyone. Welcome to another session on Microsoft Excel. In this session, we're going to be looking at basic logical functions. And what I'm going to do is I'm going to first explain what a logical test is, what a logical statement is, so that we understand when we use the if function. We don't just use it anyway. So it's only appropriate when you have a logical test. Then I'm going to talk about the components of a logical test so that we know how to write a logical test. Then we'll talk about the result from a logical test. Then we bring in the if function. It's easy to understand the if function if you know what a logical test is, what are the components, and what result we're expecting from the logical test. You're able then to apply the same function to different logical tests. So let's get right into it. The first thing that I'll do is to explain what a logical test is. When you think about a logical test, it's any question that has a result that is either a true or false. So it's binary, it's ones and zeros. Either the answer is going to be true or false. There is no in between. A logical test is only used in such scenarios. If your answers are more than two, so it can be true, false, it can be maybe, then you cannot use a logical function. A logical function is only used when you have a logical test, and a logical test is any question that will have a result that's either true or false. So what are some examples? Let's say you grade in a test, and this test there is only going to be either pass or fail. And the question that you ask yourself is the test score greater than or equal to 50? If it's greater than or equal to 50, then it's true. If not, then it's a what? It's a false. Now imagine when you're grading and you want to have A class, you want to have B class, maybe C class, D. You cannot use a logical function. Why? Because your answers are not just true or false. So if a student scores 80, then you say this is an A plus or B plus C. You cannot use logical functions there. But when your result is binary, true or false, we cannot have anything in between. It's either true or false, ones and zeros. Another example is, if you're asking yourself, is the invoice amount greater than 20,000? And the answer can be true or false. So if you have a 21,000 invoice, that's true. If you have a 19,000, that's what? That's false. Then these are the other examples. The expense claim greater than 500. Again, we're going to have a true or false. Outstanding, the number of days outstanding on an invoice, are they greater than 30? Can either be true or false. Are units on hand less than 50? Again, it's a true or false. When we are now using the if function, what it does, it gives meaning to the result. So instead of saying true, we can tell the if function to say, okay, when the result is true, you should return a pass. When the result is false, you should return a fail. Same applies here. So if the invoice amount is more than 20,000, so instead of returning a true, then we tell Excel to return a put on hold. And instead of a false, it says what? Approved. So I'm sure here you get the logic. So I'll do one more. So your days outstanding, if you have 40 days, one of your debtors hasn't paid and it's 40 days later, if you put the logical test in Excel, it will give you a true. The outstanding days are more than 30, but you want meaning. So what an if function does then, it gives meaning to the result. Then you can say, instead of true, instead of returning the value as true, Excel should say what? Overdue. That's how logical tests work. If you understand the foundation, the fundamental as a logical test, you're asking yourself a question, and this question, the result can only be true or false. That's the starting point. If the result can be true or false, then I can use the logical function. I can use the if function. But if you have more than true or false, then you cannot use an if function. It only works when the result is true or false. That's the first thing. Then the anatomy of a logical statement or logical test is you have three things that you're going to have in a logical test. You're going to have X variable, You're going to have an operator. You're going to have a decision what? Value. So I'll start by explaining an operator. So an operator, either we're going to be working with equal to or greater than, less than, greater than or equal to, less than or equal to, or not equal to. That's an operator. In any logical test, the E is going to be an operator. The operator is going to be in the middle. So you're going to have an X variable, you have an operator, and a decision what? Value. So I'll use a simple example here. So let's think of grading tests. So students have written a test and the result can either be pass or what? Or fail. You're not doing A plus B, C. It's either pass or what? Or fail. So you have your X variable, which is a value from your data. So the thing that is being tested. So you're saying, is the score of 72 greater than or equal to what? To 50. So the X variable is the value from your data. The value that you what? That you want to test. Then we have the operator, which we've explained. Greater than, less than, greater or equal to, less than or equal to, greater than, not equal to. Where do you find these signs on your keyboard? So you find them at the bottom. So next to the letter M, that's where you normally find these signs here. Then we have the decision value. The decision value is your threshold or your benchmark. So you're saying, is the score of 72 greater than or equal to 50? 50 is the threshold. That's a logical test. X variable in this case is 72, then operator greater than or equal to, then the decision variable is the 50. That's the one that we're using to make the decisions. It's our decision value. Any logical test needs to have these three. So you have the 72, which is your X value, X variable from your data. Then you have the operator greater than or equal to. Then you have decision value of 50. Anything that is going to be a result of true or false, we can write it in the same way. So let's look at other examples. Say your invoice amount. Say your invoice amount is 21,000. That's from your data. So you're saying, is 21,000 greater, that's the operator, than decision value is 20,000. So there's three components. Then you say, is the expense claim greater than 500? So you go to your data and see, what is the expense claim? Maybe it's 400. So 400 is your X value. And you say, is it greater than 500? This is what you're going to be doing for any logical test. Are days outstanding greater than 30? Maybe the invoice value from your data is 45. Then you're saying, is 45 greater than 30? Then lastly, maybe the units that you have on hand are 80. So you're saying, is 80 less than 50? So all your logical tests, you're going to have these three parts here. You have the X variable, which is the value from your data, the data that you're working with. That's where you take this X variable. Then you have the operator, can be greater than or equal to, can be less than, could be not equal to, less than or equal to. Then you have your decision what? Value. That's the value that is your threshold, the benchmark, the one that you're using to make the decision. So those two are very, very important. Once you understand these two, it's easy to set up a logical function. Very easy. So I understand that first, a logical test, the answer should either be true or false. Then the next thing is a logical test, there are three parts to it. There is the X variable, which is a value from your data. Then there is the operator in the middle, greater than, less than, greater than or equal to, has to be in the middle. Then lastly, it's your decision what? Variable. And I've given you examples here. I'm sure you can tell that this is quite straightforward. What's important is to identify, does this data need an if function? Does it need a logical what? Logical function. How you make that decision is the answer true or what? Or false? The answer has to be binary, 1 or what? 1 or 0. There is no in between. So let's look at the first example. So easy example. So we have our data here. So we have students that have scored different marks in a test, and the pass mark here is 65. And we want a pass or a failure. That's what we want. Pass or fail. So it's true or what? Or false. I'll start with just the logical test. So we say equals to, then we take our x value, which is from our data. Remember, we said our x value is the data that we have, the one that we want to test. So we're saying is 74 greater than or equal to, that's our operator. 65 is our pass mark. Then we have to absolute reference this. Either you say function F4 on your keyboard, which is Fn and F4 right at the top of your keyboard. There's an F4. Some devices you just put F4. So right at the top of your keyboard, you press F4. Then enter. And the answer here is a true. Then we copy it down. And that's a logical test. So it's given back true or what? Or false. And here we can see it's working well. 65 is, yes, is equal to 65. That's why it's what? True, because we say it greater than what? Or equal to. 59 is less than. So that's why it's returning what? A false. Now what an if function does now, it gives meaning. So we say equals to, then we say if, and you double click on it or you press the tab key on your keyboard. So the if function starts by saying, what's the logical test? And you know that a logical test has three components, three parts. It has the value that we're testing is 74 greater than or equal to. So remember, x value is from your data. So go to your data, you take the value that you want to test. Then you put the operator and what you're measuring it against. And you remember to absolute what? Reference. That when you copy your formula down, then it doesn't move. Then you go to the next argument. On my device, it's semicolon. On your device, it might be a comma. You just follow the syntax that you have on your device. Then Excel says, okay, if the value is true, what do you want me to what? To say? So an if function gives meaning. Instead of a true, then we tell Excel that we want you to put a pass. And when you're writing a formula function Excel, if you're going to use alphabetic characters, you cannot just type in pass here. You need to put the pass in open and close in inverted what? Commas. Very important. Every time you use an alpha characters, you put open and close in inverted commas. But if you're using so your number values, your 1, 2, 3, 4, you don't need to put open and close in inverted what? Commas. Then if the value is false, we want Excel to say fail. So again, my open and close in inverted commas, then type in fail. Our formula here, three parts to it. So there's a logical test first. Logical test needs to have three parts: x variable, our operator, and our threshold. Then Excel says, okay, if the value is true, what do you want me to say? Pass, want to say Excel to say fail. Important, you need to have this in open and close in inverted what? Commas. Then you enter. It's given us a pass. Then you copy it down. So you can tell here that the if function, what it's doing is given meaning to the result of a logical what? Test. So instead of a true or false, an if function then gives meaning. It can be pass, can be what? Fail. It could be put on hold, approved, overdue, not overdue, reorder, no order. It could be even what? An amount. Now, what is best practice when working in Excel? So best practice is you can name this 65. So instead of remembering to absolute reference it, we can name it. So it can be a named range. So you come to your name box here, then you give it a name, call it pass mark. Enter. So now it's a named what? Named range. I just here easily named it in the name box. So I could have gone to my formulas tab. And here under define names here, I could have defined a name, but because I'm just naming one cell here, I can easily do that by just going to what? To my name box. Then here I convert this to a table. So Control T, convert it to a table. and I have my table, and I always need to name my table. So this is test underscore. So test scores as the name of my table. When you're naming your table, you cannot put any space. So yeah, I use an underscore. I'm not going to design my table here. Then I come here now, I enter my if function. So I say equal to if. Then I do my logical test, 3 parts. There's the x variable, the thing that is being tested. Is it greater than or equal to? I can come here and click on the pass mark, or I can just type pass mark because it's a named range. Then it will come out. Then if the value is true, what do I want Excel to say? I want Excel to say pass. If the value is false, I want Excel to say fail. So that's one way of doing it. But for many people, if you're a beginner, so what you might prefer, so you might be forgetting to put the open and close inverted commas. So what you do is, once you get here, so you can come here next to your formula bar here, next to where you put your formula here, you come next here, and you double click here on the FX. Then value if true, then you just put a pass. Then Excel will put the open and close inverted commas for you. Then value if false, you put a what? Fail. And Excel will put the close in and what? Open inverted commas for you. Then equal to. And because I'm in an Excel table, the formula auto propagates. So it fills in going what? Going down. So that's best practice when you're working in Excel. Your threshold, you can give it a name. You can have a named range. Then you convert the data that you're working in into a table. Then you enter your formula. The formula looks much better. So you can easily read through the formula. You can understand what's happening. So we're saying, is the test score greater than or equal to the pass mark? Then we get a pass or what? Or fail. So that's it on this first part. So I'll look at more examples in part 2. We'll be following the same what? The same foundational concepts. Just adding more examples so that we're all comfortable with the content. So I hope this was really helpful, and I hope you're able to follow along with everything and you can actually practice. So you can stop and try maybe another example before we look at another example together. So that's it for part 1.